Hello boys and girls, and welcome to lesson 4-2 using negative exponents. You'll find this lesson on pages 141 to 143. Now here's what we're going to learn. We're going to write expressions using negative exponents, and we're going to evaluate numerical expressions containing negative exponents. So we're actually going to work with negative exponents. Now let's see what this means. Here we have the key concept, and sometimes when we read these sentences they can be a little confusing, but all they're trying to say is that a, for example, a is our whole number, okay, it's our base. It cannot equal 0 for this in order to happen. If it equals 0, then our number is just going to be 0. So here's an example where we have n is the exponent, and we have a as our base and n is our negative exponent, and all that means is that it becomes a fraction under 1, okay, and we remove the negative. So it's 1, okay, over a to the power of n. If we actually look at an example, we have negative 2. To get rid of this negative 2 exponent, we put it under 1. So now it becomes a fraction. You see that? Okay. This is why negative exponent becomes a fraction. As you can see, we have 10 to the power of 3. Let me zoom this in. We have 10 to the power of 3 is 10 times 10 times 10, which equals 1,000. 10 to the power of 2 is only 10 times 10, so we're dividing it by 10. We're taking away one of these 10s. When you take away one of the factors of 10s, you're actually going down by 1 0, so you're dividing it by 10, as you can see right there. Okay, 10 to the power of 1, it's 10. Another way to look at it is 10 to the power of 3 is 3 zeros. 10 to the power of 2 is 2 zeros. 10 to the power of 1 is only 1 0. 10 to the power of 0 means no zeros. So 10 to the power of 0 is just 1. Any number to the power of 0 is 1. And then we have 10 to the negative 1, it's going to be 1/10. The decimal has been moving over to the left each time. You see that? Now it's 1/10, 0.1. Okay? And 10 to the power, 10 to the negative 2 power is 1/100th. And 10 to the negative 3rd power is 1 over 1,000. So it's 1 in the 1,000th place. If you were to write it as a decimal, you see that you have 0.1, 1/10, right? You can also, if you want to remember a quick trick, is that when you see that it's negative 1, it's the 1 in the first decimal place, not the ones, because there's no ones. It's in the 10th, but it's only one decimal place in. Here we have 2 decimal places in, 1, 2, and over here with the negative cubed, we have 3 spaces in. That's another way to remember it. Okay, please pause the video and take a look at example 1 and 2 so that you can see how a negative exponent, okay, with the base of 2 is converted into a fraction. Okay, you can see it also with a variable right here. Take your time to take a look at this, how it works, and then solve 1A, B, and C, and then you can check the video. So pause now, please. So let's see, 3 to the negative 5, 3 to the power of negative 5 is going to be, remember we put it over 1, and that gets rid of the negative, and now we have 3 to the power of 5. Okay? If you wanted to really solve it and tell me what fraction that is, you would have to multiply 3 into itself 5 times. Okay? And now we have 1, again 1 over y to the 3rd power. We don't know what y is, so we leave it like that. And then we have 2 to the power of 0. 2 to the power of 0 is simply and always 1. Okay, in example 2, when you look at it, you'll notice that we're going backwards now. Now we're given the fraction and we want to reverse it. So we take away the numerator 1 and we convert it right back to a negative exponent. As you can see, okay, we have 1/100th. 1/100th is 1 over 10 to the power of 2, or 10 negative 2, right? Okay, take a look at this carefully. Remember, I was explaining that this is the same as writing 0.01. Okay, I really want you to try these 3. Go ahead and pause the video now and try them. Okay, so now since we're working backwards, we simply remove the 1. We have our base of 6, and it now becomes a negative exponent, negative cube. Okay, again we remove the 1. Okay, but you notice that this is 25, and 25 is the square root of 25 is 5. So it's 5, our base is 5, and because we remove this 1 right here, it becomes negative exponent cube. Remember, 5 times 5 is 25. Okay? And now we have 27. We remove the 1. Okay, we remove the 1, and it would simply be 27, but 27 is actually 3 times 3 times 3. So it becomes, our base is 3 to the negative 3. Okay, to the power of negative 3. Example 3, we have a word problem. Okay, let's read it. Geckos have tiny hairs on the bottom of their feet that are about 1/1,000,000th meter long. Write the decimal as a fraction and as a power of 10. Okay, so here we have 1/1,000,000th. How many zeros do we have? 1, 2, 3, 4, 5, 6. So we know it's 10 to the power of 6. There it is, 1 over 10 to the power of 6, and because we want to get rid of the numerator 1, we write it as a negative because we know this is going to later be written as a fraction, right? Because it's a tiny, tiny number. Okay, let's try 3a and b. 3a, remember to pause the video please if you haven't yet, read it, try it on your own, and then check to make sure that you did it correctly. The slowest moving fish is a seahorse. It swims at a maximum speed of 1/10, 100, thousands, 10,000. Okay? 10,000ths mile per minute. Write the decimal as a fraction and as a power of 10. So 1, 2, 3, 4. It's in the 4th place. So I would just simply write it, okay, as 1 in the 10,000th place, right? But since we know that we have 4 zeros, we can also write it as 1 over 10 to the power of 4. Oh, that's a big 4. Let me erase that. This would be an exponent, 10 to the power of 4. And we could also write it as, if we want to get rid of the 1, 10 to the negative 4th power. I hope this makes sense to you. Okay? Remember, number placement is important. 10th, 100th, thousandths, 10,000. So we wrote 1 over 10,000. We wrote it with using an exponent. Remember, we just count the number of zeros, and then we make it as a negative. I also mentioned in class that we use these numbers to the base 10, okay, to describe very tiny numbers, or very tiny things, or very large things. For example, here we have 10th, 100th, thousands, 10,000s, 100,000. So this is 100,000ths of a gram. It's a tiny, tiny, tiny weight, tiny mass. So let's try it. The smallest species of ant has a mass, a weight, a size and weight of 100,000ths gram. Write the decimal as a fraction and as a power of 10. So let's do it as a fraction. 1 over 100,000. Right? And then we do it, how many zeros do we have here? 1, 2, 3, 4, 5. Then we do it as a base 10. There's our base 10 to the power of 5. And then if we want to get rid of the numerator number 1, and we write it as 10 to the negative 5. I hope this is making sense, boys and girls. And here's the second part of the lesson where we're going to learn algebraic expressions containing negative exponents can be written using positive exponents and then evaluated. Okay, so what they're meaning is, take a look here. Take a look at example 4. Okay, I hope you paused and looked at it. Now, what we're doing here, boys and girls, is we're going to evaluate 4a to the negative 5th power, okay, if a is negative 2. So what we do is we replace the variable, as you see there. We work with the order of operations, so we have to work with the exponents first, solve what the exponent means, okay, figure out, multiply the exponent, and then multiply a whole number times a fraction, which we already know how to do. You cross-reference, you see the cross-referencing right there, and then we have 1 negative 8, or negative 1/8. If that didn't make a lot of sense to you, please pause the video and really look at this in your textbook and read each step at a time. Now that you have it figured out, let's go ahead and try 4a, b, c, d, and then play the video again to check to see that you did it correctly. Alright, I hope you paused the video. Let's do 4a. M equals 4, right? M equals 4, so I'm just going to go right ahead and write it as 4 equals negative 2, which is the same as saying 1 over 4 to the 2nd power, which is the same as saying 1/16, because 4 times 4 equals 16, right? Let's try B. It's going to be 6 times 4 times n is 3, right? 3 to the negative fourth power. So now, following the order operation of PEMDAS means we have to do parentheses first. There's nothing in the parentheses, but we do have an exponent. So this exponent applies to the 3. Okay, actually, I should have drawn that a little bit differently. Instead of putting the parentheses there, I should have put it there. Okay, because it belongs to the 3. So ignore that there. Sorry for the mess. Okay, so 6 times 4 and times 1 to the third power over 3 to the fourth power. Okay, now we have now I can just go ahead and solve the exponent. I have 6 times 4 again. 6 times 4 times 1 over 3 times 3 times 3 times 3 equals 98. Okay, now I can just go ahead and solve through. 6 times 4 is 24. 24 and times 1 over 98. Right? I'm going to place this over 1. I'm going to multiply straight across, or I can cross-reference. These are both multiples of 8. Right? On the top, I have actually no, they're multiples of 3. They're both multiple. This one, the 98 is not a multiple of 98. This is multiple of 3. So I have 3 8s here on the top, and on the bottom, if I would divide this by 3, I have 27. Right? I took away one of those exponents. So now my answer is going to be 8 times 1 is 8, and 1 times 27 is 27. So it's 8 over 27. Sorry about the mess, boys and girls. I don't have a lot of room here to work with. Okay, let's try 4C. So we replace the n with a, right there, n with the 3. So it becomes automatically negative 3 because it's negative n to the exponent of negative 3. And now we have negative 1 over 3 to the power of negative 3. And 3 times 3 times 3, remember it's a negative, it's going to equal negative 1. Oh, sorry, this right here, this little guy is not supposed to be negative because we put it over 1. Sorry for my silly mistakes. Okay, it's over 27. So it's negative 1/27. And lastly, let's replace the variable for 4D. We have negative 4. M is times 4 to the power of 2, negative 2. So again, I have negative 4 times 1 over 4 to the power of 2, which is, I'm just going to go right to it and make it 16, because we know 4 times 4 is 16, right? And then I place it over 1. I can cross-reference. Okay, right here, I have 1 4 there and 4 4s there, right? And then I can just go right ahead and multiply negative 1 times 1 equals negative 1, and 1 times 4 equals 4. So it's negative 1/4. Okay, now we have our guided practice. As always, please leave this for class. We will do this as a warm-up so we can get ready for our class work. And we have a ton to do for independent practice. The independent practice is quite long. If you look at this, I want you to actually do this section of the independent practice, just the bottom on page 143. Just go ahead and do that part. And we'll do 144 in class. 144 will be done in class. So let's just leave these for class. We'll work on it together. As well as 145, you see right there. So yeah, let's leave this work for class, boys and girls, so I can answer any questions. Take a look at that number. That is insanely small part of a second. Okay, see you in class, everyone.